lesson on section 2.4, complex numbers. A complex number is basically defined as I is equal to the square root of a negative 1. So anytime you have a negative inside a radical, to simplify, it comes out as being an I. So if you have I to the first power is equal to I squared is negative 1, I to the third is negative I to the fourth is 1. And this is just a pattern that repeats. So I to the fifth would just be I to the sixth, negative 1, I to the seventh, negative I, and I to the eighth is 1. And then the same thing for the next row. So how do I figure out what I to the 50th is? The easiest thing to do is do 50 and divide it by 4. So that would go in there 12 times with a remainder of 2. The remainder is what is I. So now I'm at I squared. I squared is equal to negative 1. So I to the 50th is equal to negative 1. Same thing for 67. So I take 67, divide it by 4. That goes in there 16. So the remainder is 3. So I to the 67th is the same thing as I to the third, which would be negative I. And then 24 divided by 4 goes in there evenly, so the remainder is 0. Well, that puts us, when it goes in evenly, it's back here at like I to the fourth. So this equals I to the fourth, which would equal positive 1. Dealing with operations, you add and subtract as if you were looking at any variable. So the imaginaries combine with imaginaries, the real part combine with reals. So positive 2i would combine with the negative 2i to cancel each other out. So the answer is just negative 4. Here, combining, make sure this minus distributes. So minus a negative 2 plus a negative 5. And then you'd have a negative 3i plus an I. So combining this down, you have positive 5 and a negative 5 goes to 0. And then negative 3i plus I would be minus 2i. So your answer is just negative 2i. Right here, combining our reals, 3 plus 4 minus 7. So 7. So 7 minus 7 goes to 0 for the real part. And then positive 2i minus I would be an I. Minus I also cancels out. So your final answer is just 0. Right. Multiplying. You always want to deal with your i's first. So dealing with a negative 4, the square root of that would just be 2i. With this negative is going to be an I. The square root of 16 is 4. So then I'd have 8i squared. I squared is equal to negative 1. So my answer is negative 8. Squaring this out, you would FOIL. So 3 times 3 is 9. Plus 6i. Plus another 6i. And then 2i times 2i would be 4i squared. I can combine the 6 i's to get 12i. And I squared is a negative 1. So this becomes a minus 4. So 9 minus 4 would be 5. So my answer is 5 plus 12i. Same concept here, distributing 2 times 4, then 2 times 3i. Negative I times 4. And then negative I times 3i would be a minus 3i squared. Combining my like terms, the 6i minus 4i would be 2i. The I squared would be a negative 1, so this becomes a plus 3. So my final answer, 8 plus 3 is 11 plus 2i. And then the last problem, I'm going to go ahead and simplify my parenthesis. So that would be a 3i, and then 2 plus 3i. So foiling, 2 times 2, 2 times 3i, negative 3 times 2, and then negative 3i times 3i would be negative 9i squared. The 6i's would cancel out. I squared is negative 1, so that becomes 4 plus 9 to give me a final answer of 13. The last concept is division. When you divide, you multiply by the conjugate. The conjugate is where you change the sign of the imaginary part. So I'm going to multiply numerator and denominator by 1 minus I. So distributing in the numerator, I just have 1 minus I. Foiling the denominator, 1 times 1, 1 times negative I times 1, and then I times negative I. If you did it correctly, your middle two terms will cancel each other out. So I have 1 minus I over 1 minus I squared. I squared is a negative 1, so this will end up being 1 plus 1. So I'd have 1 minus I over 2. And then to go to standard form is an A plus BI form. So you split it 1 over 2 minus, and this becomes I over 2, or 1/2 I. On the second one, I'd multiply by 4 plus 2i over 4 plus 2i. Foiling the numerator, I have 8 plus 4i plus 12i plus 6i squared, all over 4 times 4, so 16. I know my insides and outsides are going to cancel, so I don't have to worry about it. So in the numerator, remember this is going to make this a negative 6. So I have 8 minus 6 to be 2. 4i plus 12i is 16i. This I squared will make this become a plus 4. So 16 plus 4 is 20. Splitting the fraction up, 2 over 20 plus 16i over 20, and then reducing. So 1/10 plus 4i over 5 would be my answer. And then the last one, multiplying by negative I. So I would have negative 3i minus I squared over a negative I squared. So up here it's going to become a negative 1. So I'd have negative 3i minus a negative 1 over the opposite of a negative 1. These are going to become a plus sign, so I'm going to have 1 minus 3i, and this become a positive 1 where you don't have to have your denominator. And the last concept is graphing. What happens is your vertical axis, your y-axis, becomes the imaginary number line, and your horizontal becomes the real number line, or the axis. So you go in the x direction, your real number, your y direction, your imaginary. So I'd go over 2 and up 3. So there's point A. So I'd go left 1, up 2. So there would be point B. This doesn't have any imaginary, so I would just go over 4. And then this last one, I have no real, so I don't go over any, I just go down 3. And that is your lesson on complex numbers.